So the big idea of Newton's first law is that forces are going to be balanced. So that means the motion is not changing, right? So an object at rest is going to be at rest, or an object with constant velocity will stay at that velocity. So the motion's not changing. The forces are equal in size and magnitude, but opposite in direction, and the net force is equal to 0. So for Newton's first law, it's called the law of inertia. And again, a motion is going to stay in motion unless it's acted on by a net external force. So like if you're on a hockey rink and you hit a puck, that puck on the ice is going to continue moving with constant velocity until some other guy hits it or it hits the wall. Okay, an object at rest is going to stay at rest. So a water bottle, it'll stay there until you pick it up or push it over. It can get knocked over, but even if it gets knocked over by something, that something knocking it over is still an applied force. So that would be an external force on the water bottle. Now inertia, okay, inertia is actually just the object's resistance to change in motion. Okay, so if you have a hanging mass and it's just hanging there, it doesn't want to move. It just actually wants to hang, right? And the more massive that hanging weight is, the harder it is to move. The harder it is to move something that's at rest, the more inertia it has, okay? So the other idea is also something in motion. So like if you have a train, it's really hard to start a train. There's a lot of forces and a lot of mechanics going on to get that train to even start motion. But if it's in motion, in constant motion, it's actually hard to actually accelerate it or to make it come to a stop. Okay, and it's because a train has a lot of inertia. Versus if you have like a little kid and you want to move them out of the way, you just kind of move them out of the way, right? Because a little child, in comparison to a train, has very, very, very small inertia. So it turns out that inertia really does have a lot to do with weight. So if we compare here, I have this eraser. This eraser is like next to nothing. I think my marker is actually heavier than the eraser, okay? So to get this eraser motion, what I'm going to do, I'm just going to take this cart and I'm just going to push, and I'm going to see how easy it is or hard it is to move the eraser. Now I push this and the eraser moves very, very easily. So this eraser has little inertia, or more importantly, it has less inertia than the force being applied by this cart. Okay, now if I take this mass, right, a lot heavier in comparison, this mass is about twice the mass of this cart. So when I take the cart here and I move the cart in the same manner, right, now the weight did move a little bit, but not as much as the eraser, right? So same cart pushing on it, but this has more inertia because it resists changing its motion more than the eraser resists changing its motion. So Newton's law of inertia is the idea that every object doesn't want to change, and the more inertia you have, the harder it is to change your motion. That is what inertia means, okay? And then the one thing we already know, equilibrium means that the net force on the system is 0, okay? So if I have upward forces and downward forces, they have to be the same. If I have leftward and rightward, they have to be the same size, so the same magnitude, but they're going to be opposite in direction. So we just have a couple of little comics here, and then these really describe Newton's law. So this soccer ball is just sitting here. Everybody agree? It's just at rest, and it's actually going to stay that way until someone kicks it or something, right? It has to have some force working on it. So if the wind blows really hard, right, that would be a force maybe enough, right, to make it move. But here, the object's at rest, it's going to stay there unless you have some outside force working on it. So here, the net force is equal to 0. Here, we apply a force. This force gets it into motion. Okay, now there are other forces working here besides gravity and air resistance, right? But we're not going to get into the aerodynamics. The idea is that this object is now in motion and it wants to stay that way until there's a net force making it unbalanced and causing it to come to a stop. Okay, and so I like this one because for this we have this guy and he's in motion and the bike's in motion. Now what's happening here? Right? So the bike runs into a wall. Now the bike and the guy are in motion, but what happens to the bike? The bike stops and the guy, he flies. Why does he fly?
bike or something. He's not actually the bike or something.
Right? So the force is only working on the bike, right? The brick wall is stopping the bike, but the brick wall is not stopping the guy. And the guy is in motion, so by Newton's first law, he wants to stay in motion, right? So he is staying in motion here, right? The bike stops, he stays in motion. That's why he goes flying. So if you guys remember ever being like pulled in a wagon, right? And you're sitting in the back of the wagon, you're at rest, wagon's at rest. Someone grabs the wagon and they pull hard. Now you're at rest, so what do you want to do? You want to stay at rest. So when someone pulls hard on the wagon, what does your body do? You start to fall out, right? Because your body is trying to stay in the same place while the wagon starts moving in motion.